Hi everyone, I'm Pratima. I welcome you all to my channel. I thank all the subscribers for subscribing and supporting. In this video, we'll learn 10 definite integral question from JEE main. So let's begin one by one. Question is evaluate 2y sin y over 1 plus cos square y with respect to y. The limit is negative pi to positive pi. We have to integrate. So here we'll put the properties, that is a function from negative a to positive a, f of x dx. This integral is same as 2 times of 0 to a f of x dx if f of x is your even function and it is 0 if it is a odd function. So how to know it is a even or odd? If f of negative x is same as your f of x, then it is a even function. And if f of negative x is same as negative of fx, then it will be an odd function. So here, if we'll use f of negative y, we'll find that this is 2i is negative y into sine negative y whole over 1 plus cos square negative y. This is same as your sine negative y is minus sine y. So it will be 2y sine y over 1 plus cos square y. That is your f of y. So this is an even function. So we can use the properties what I have mentioned. So f of y is even. So now applying the property, we'll write that. So negative pi to pi integral equals to twice y sine y over 1 plus cos square y dy equals to same as 2i is 0 to pi 2y sine y over 1 plus cos square y dy. So applying this property since fy is even function. So next we will apply the property. Applying the property, this is a very common property. 0 to a f of x dx is same as 0 to a integral of f a minus x dx. So let me multiply here. It will be 4 times of 0 to pi y sine y over 1 plus cos square y. This is your integral denoted by I. Now applying this property, I'll get I equals to 4 times 0 to pi. Instead of y, we'll write pi minus y and sine again pi minus y. Of course, in the denominator, we have to apply that same thing, cos square pi minus y. This equals to 4 times 0 to pi minus y, and sine pi minus y is again sine y, and cos pi minus y is negative cos y, but since we are getting square, it will be cos square y. So next, this I integral and this integral, I'll add them. So adding to this expression, I'll get twice I equals to 4 times 0 to pi sine y over 1 plus cos square y dy, and here plus 4 0 to pi pi minus y sin y over 1 plus cos square y dy. So on adding, I'll get 4 times 0 to pi sin y. It's not pi sin y, it is pi y sin y. Very sorry. First one was y sin y. And here pi sin y minus y sin y whole over 1 plus cos square y dy. So here this 2 will be cancelled. So this will be 4 times 0 to pi sin y over 1 plus cos square y. So now on simplifying, I'll get I 2 will be cancelled with 4. This gives us I is equal to 2i is pi, I'll take outside, 0 to pi sin y over 1 plus cos square y dy. To integrate this, I'll take cos y, let cos y is equals to t, then minus sin y dy, its derivative equals to dt, or sin y dy equals to minus dt. Now coming to limit, cos y equals to t, so lower limit is cos 0 is 1, then upper limit is cos pi, this will be negative 1. So whole thing is changed to I now, t now. So this will be 2i pi 1 to negative 1 minus dt over 1 plus t square. Or this can be again used property to remove this negative sign. I can change the limit negative 1 to positive 1 dt by 1 plus t square. And we know the integral, this is very common, that is tan inverse t. So 2i pi tan inverse t from negative 1 to 1. So I equals to 2 pi multiplies tan inverse 1 minus tan inverse minus 1. Tan inverse 1 is pi by 4. This will be negative pi by 4. It will be again positive pi by 4. So this will be 2 pi multiplies pi by 2. Or this answer is pi square. So integration of negative 2 pi 2y sin y over 1 plus cos square y with respect to y equals to pi square. Question is, evaluate integral f of x dx. The limit is, lower limit is 0 and upper limit is 2, where f of x equals to maximum of x square and 1 plus greatest integer function x. And it is given that this box x denote the greatest integer function. So let us write this greatest integer function. Okay. The question is, what is f of x? F of x is maximum of, we have to choose between x square and 1 plus greatest integer function. And what is greatest integer function? That this equals to is the greatest integer less than or equal to x. Then we have to break it into the intervals. How will break? This is your from 0 to 2 fx dx. So interval is first 0 to 1. Let us write the intervals. First intervals is your 0 to 1. That means x is greater than equal to 0 and less than 1. So that time greatest integer function value equals to 0 because it is less than the itself. And second interval is your greater than equals to x plus less than 2. So that time this greatest integer function takes the value, or we say it floor function, it will be 1. So first interval is case 1, when the interval is 0 included and 1 is not included, or 0 is closed, 1 is open. That time greatest integer function is takes the value 0. So that time f of x, which is your maximum of x square, and 1 plus greatest integer function is 0. So 1 plus 0, that is 1. So I'll take maximum of x square and 1. So now it is interval is x is in between, not in between, greater than equals to 0 and less than 1. That time x square equals to less than 1. So what will be the maximum? Maximum will be taking the value of 1 because x square is less than 1 and this is 1. So fx is 1. So in the interval 0 to 1, we are taking fx is 1. Next, in the case 2, when it is your 1 to 2, interval is 1 to 2, that time we are taking the greatest integer function is taking the value 1. So let us find the maximum of the value, maximum of x square and 1 plus 1, maximum of x square and 2. So here again we will find two conditions or two intervals. What if x is greater than equal to 2? That time, x square is greater than equal to 2. That time your x is greater than equal to square root 2. Square root 2 means it is approximately equal to your 1.41. So here there are two cases. One is for x is greater than equal to 1, less than square root 2. That time fx is equal to x square, because x square will be greater than 2. And for square root 2, x is greater than equal to square root 2 and equals to 2, less than equals to 2. That time fx is equal to x square. Oh, I committed a mistake. It will be, this is 2. 2 is greater here. Okay. So now we'll break into 3 intervals. So 0 to 2 f of x dx is same as your 0 to 1. That time fx will take the value of 1, and 1 to square root 2 fx and square root 2 to 2 fx dx. This equals to 0 to 1, 1 dx, 1 to root 2, 2 dx, and root 2 to 2, it will be x square dx. So now easy for us to calculate. So 0 to 2 f of x dx equals to, here x from 0 to 1 plus twice x to square root 2 plus x cube by 3 root 2 to 2. So we'll do the calculation. It will be 1 plus 2 root 2 minus 2 plus 8 minus 2 root 2 over 3. Total is your minus 1 plus 8 by 3 plus 4 root 2 by 3. This will be 5 plus 4 root 2 over 3. So this is the answer. So the question is, evaluate the integral 136 sin x over 5 sin x plus 3 cos x with respect to x from limit 0 to pi by 4. So what I'll do, I'll take 136 outside. I'm not claiming that this is the only method. Integration can be solved in many methods. So 136 I'll take outside and I'll divide a 34 both in the numerator and denominator. So that the numerator will be 34 sin x and 5 sin x plus 3 cos x. And why it is directly I wrote 34, I'll just explain. So here it is. In the next step, you can see that there is no cos x in the numerator and the derivative of this numerator is not denominator is not numerator. So what we'll do, we'll break this numerator in this technique. How? Let this equals to a some constant into the denominator plus another constant or arbitrary constant b into the derivative of the denominator. So it will be 5 cos x minus 3 sin x. In the next step, what we'll do, we'll compare the coefficient of sin x and cos x. So let's simplify this. So 5a sin x plus 3a cos x plus 5b cos x minus 3b sin x equals to 34 sin x. Now comparing the coefficients. Sin x and cos x separately. In the left side, I'm getting sin x and sin x. So 5a minus 3b, and the right side, the sin x is 34. So this is equation 1. And second is cos x. Cos x. Here there is no cos x, so I'll imagine it is 0 cos x. So 3a plus 5b equals to 0. Now we'll solve these two equations. Solving. So you can multiply 3 in the equation 1 it gives us 15a minus 9b equals to 102. And second equation I multiply with 3. So 9a and not 3, it will be 5. First equation with your 3, second equation with 5. So it will be 15a plus 25b equals to 0. Here subtracting, we get 34b equals to negative 102. So b equals to 3. Now putting in equation 2, we get in the equation in 2. So 3a equals to 15 or a equals to 5. So we'll take the numerator in with two components. The equation was 136 over your 34. It can be your 4, 5 by 4. First was a is 5 into the same numerator, 5 sin x plus 3 cos x over 5 sin x plus 3 cos x plus b, b is negative 3 into its derivative, so 5 cos x minus 3 sin x over 5 sin x plus 3 cos x dx. So first one we can see that it is only 5. With respect to dx, its integration will be 5x. And second one will be, if I take the denominator as t, this numerator is dt, so this will be minus 3 over dt by t integration. Of course, for second it is not 0 to pi by 4. From this it is 0 to pi by 4. It is not, it will be something else. So I'm taking the limit for this. After that we'll use. So this will be 4 into 5 pi by 4 minus 0. So 5 pi by 4. This will be 3. And dt over t is log t, we know. Log t, what is t? We have taken this denominator. So 5 sin x plus 3 cos x. And here we will put the limit, that is 0 to pi by 4. Now put the value correctly. This will be 4, 5 pi by 4 minus 3 log 5 sin pi by 4 is 1 by root 2 plus 3 into 1 by root 2 pi by 4 is 1 by root 2. Then minus log, here it will be sin 0 is 0, and this will be 3 cos 0. Cos 0 is 1. So what I am getting? Ultimately we are getting, I am multiplying the 4 now. So it will be 5 pi, 4 cancel. It will be 4 into 3 log 8 by root 2 minus 12 log 3. It will be plus log 3. Again, there is a minus, so plus plus. Very sorry. Minus minus minus. It will be plus log 5 pi minus 12 log 8 by root 2 over 3. 5 pi, the answer was in this form, so I am just changing it. This will be 4 root 2. To make it a square, I'll keep here 6, and this 2 will be in power log 4 root 2 over 3 power 2. So this will be 5 pi minus 6 log 32 over 9. This is the answer. Question is, evaluate the integral t4 power 4 plus 1 over t power 6 plus 1 with respect to t from limit 1 to 2. So only thing is, we have to break this numerator so that we can be able to do this. So let's see. You will see the denominator is t to the power 6 plus 1. It can be factorized into t square plus 1 into t to the power 4 minus t square plus 1. So t power 4 plus 1, the numerator, I can convert in term of factor of denominator like this. So plus 1, 1 negative t square and plus positive t square. So writing the numerator in this way, t4 plus 1 minus t square plus t square, and the denominator in factor form t square plus 1 into t4 minus t square plus 1 whole dt. So we'll make into 2. One is 1 to 2 t4 minus t square plus 1 over t square plus 1 into t4 minus t square plus 1 dt, and second one is only t square is left over these two terms, but I'll keep this in original form. Now you will see the integral 1, these two are cancelled. Integral is 1 is becoming only dt by t square plus 1. This 2 will be cancelled, and integral 2 equals to 1 to 2 t square dt over t6 power 6 plus 1. First one is very easy because we can put the direct formula that will take tan inverse t from 1 to 2. So tan inverse 2 minus tan inverse 1. Tan inverse 1 is pi by 4. So this will be tan inverse 2 minus pi by 4. For integral 2, I'll take t cube as your y, then t power 6 equal to y square, and 1 by 3 t square dt. T square dt will be 1 by 3 dy. So I2 will be 1 by 3 dy over y square plus 1. This is same as your 1 by 3 tan inverse y. Tan inverse y equals to 1 by 3 tan inverse t cube. And this is from 1 to 2. So I2 equals to 1 by 3 tan inverse 2 cube, that will be 8 minus tan inverse 1. Tan inverse 1 is again pi by 4. So 1 by 3 tan inverse 8 minus 1 by 3 into pi by 4. Now the sum of all the results I1 plus Y2 equals to tan inverse 2 minus pi by 4 plus 1 by 3 tan inverse 8 minus pi by 12. This was 4 by mistake. I have taken 12, it will be 4, sorry. So it will be pi by 12. So total result will be tan inverse 2 minus pi over 3 is of course 1 by 3 tan inverse 8. So integrate tan inverse x over x with respect to x from half to 2. So here many properties are involved. So let us go step by step. We'll take x equals to 1 over t. Then your tan inverse x will be tan inverse 1 by t. And when x is 1 by t, dx equals to your minus 1 over t square dt. Then coming to limit, x when lower limit is half at t equals to your 2, and when x equals to 2, t equals to half, because t is 1 by x. So limit will be changed or it will be reversed. It will be your tan inverse 1 by t over 1 by t multiplies minus 1 over t square dt. So in the next line, this t will be cancelled with t. So it will be 2 half tan inverse t over t, tan inverse 1 by t over t dt. There is a negative sign here. So again I am using the property. I'll remove this negative, changing this limit. So it will be again half to 2, and tan inverse 1 by 2 t can be written as your cot inverse t or t dt. Next, using the property a to b f of x dx is same as your a to b f of t dt. So replacing t by x, this can be written as 1 half to 2 your cot inverse x over x dx. New I, and previous I was given that half to or original was tan inverse x over x dx. So I'll add this to I'll get, adding them, we'll get twice I equals to half to 2 tan inverse x plus cot inverse x over x dx. And we know that tan inverse x plus cot inverse x equals to pi by 2 over x dx. And dx over x is equal to, this integral is log x. So twice I equals to pi by 2 log x. The limit is half to 2. Twice I equals to pi by 2 log 2 minus log half. This is equal to pi by 2 log 2 over half. 2 over half will be 4 only. Log 4 is, I'm simplifying to match the answer, pi by 2 log 2 square, that is same as 2 pi by 2 log 2, I equals to pi by 2 log 2. This is answer of this question. So half to 2 tan inverse x over x dx equals to pi by 2 log 2. Evaluate the integral 0 to 10 greatest integer function into e power greatest integer function over e power x minus 1 dx. The answers are 45 multiplies e minus 1, 45e plus 1, 9e minus 1 and 9e plus 1. So let us define the greatest integer function. The greatest integer function is takes the value which is less than x. That means if we will go for 0 up to 1, the greatest integer function value takes the value of 0. Similarly, 1, 2, up to 2, it takes the value your 1, so on. So that means from 0 to 10, it can take value 10 values. So we have to divide into 10 intervals. Before that, let us simplify the expressions. So integration of 0 to 10, this integral greatest integer function e to the power greatest integer function whole over e to the power x minus 1 dx equals to your 0 to 10 greatest integer function e power greatest integer function minus x plus 1 dx. So after getting this, let us divide into different intervals. So I'll write I equals to 0 to 1 greatest integer function into e to the power greatest integer function minus x plus 1 dx plus 1 to 2 greatest integer function e to the power greatest integer function minus x plus 1 dx plus 2 to 3 greatest integer function e to the power greatest integer functions, or we say box function dx, so on, and the last is your 9 to 10 e to the power x prox x minus x plus 1 dx. So we'll go one by one. First is when it is 0 to 1, this takes value 0. So it will be just 0. 0 integration is 0. Next, coming to second one, please observe carefully. This will be 1 and here it will be 1 minus 1 plus 1. That means e to the power 2 minus x. So here it will be 1 into e to the power 2 minus x dx. Now please observe your third term. When we are writing 2 to 3, this will take the value of 2. Multiplies, here it will be 2 plus 1, 3 minus x. E to the power 3 minus x. 3 minus x dx. So what will be fourth term? Fourth term will be 3 to 4. It will be 3 into e to the power 4 minus x dx. And coming to the last term, it will be 9 to 10. 9 into e to the power 10 minus x dx. So integration is easy. Now after getting this value, so it will be e to the power 2 minus x is same as your e to the power 2 minus x upon negative 1 from your 1 to 2. Third term will be e to the power 3 minus x over negative 1, 2 to 3, again 2 is outside, plus 3 into e to the power 4 minus x over negative 1 from 3 to 4. And what will the last? Last will be 9 into e to the power 10 minus x over negative 1, 9 to 10. So evaluate the integrals now. I equals to negative 1, I can take common. First term will be e to the power 0, 2 minus 2 0, e to the power 0 minus e. Next will be 2 into e to the power 0 minus e, 3 into e to the power 0 minus e, and last will be 9 into e to the power 0 minus e. E to the power 0 is 1, so 1 minus e, 1 minus e, 1 minus e will get a serial terms. I is equal to negative 1 minus e I took common, so it will be 1 plus 2 plus 3 up to 9. So this is equals to I equals to negative, here 1 minus e multiply, it will be 9 into 10 over 2. So it will be 45 minus 45, 1 minus e, or I is equals to 45 into e minus 1. So this is the answer. Now let us check which one will be answer. 45 e minus 1, first one will be the answer. So 1 is answer. Question is, evaluate the integral x plus pi by 4 over 2 minus cos 2i x dx from limit negative pi by 4 to pi by 4. So I am making it into two functions. One is I equals to negative pi by 4 to pi by 4. One is x over 2 minus cos 2x dx plus negative pi by 4 to pi by 4, pi by 4 over 2 minus cos 2x dx. So first integral is I1, this is I am naming y1, this is I2. See, for I1, when integrating I1 is an odd function. X over 2 minus cos 2x is odd. Why? If you put x, negative x in place of x, it will be minus of fx. So what is the use of odd function? The properties of the integral, definite integral, says that when the function is odd, minus a to a fx dx equals to 0 if fx is an odd function. So integral 1 is 0. Coming to integral 2 equals to negative pi by 4 to pi by 4 dx upon 2 minus 2 cos 2x. It can be written as 2 to 0 to pi by 4 dx by 2 minus cos 2x. What is the properties we are applying? Applying that integration of negative to a to positive a fx dx is same as 2 times of 0 to a fx dx if fx is even function. It means when f of negative x is same as fx. So I2 equals to twice pi by 4 I can take outside 0 to pi by 4 dx over 2 minus cos 2x equals to, now you can solve it in your own way. But how I am using, I will put the cos 2x as tan function. So this is 1 minus tan square x over 1 plus tan square x. This equals to pi by 2, 0 to pi by 4, 1 plus tan square x, which will be in the numerator, that will become 6x square x. And here we'll get 2 plus 2 tan square x. Simplifying this one, minus 1 plus tan square x. This will be 2 plus 2 tan square x. So this is equals to pi by 2 to 0 to pi by 4 x square x dx over your 3 tan square x plus 1. I will take tan x as t, then its derivatives x square x dx will be dt, but you have to change the limit also. Here the lower limit is your x plus 0, that means tan x, or that is t, equals to 0. So lower limit is again 0. And when x equals to pi by 4, t equals to tan pi by 4, that will be 1. So integral 2 is becoming now pi by 2, 0 to 1 dt upon 3t square plus 1. Or this is pi by 2, 0 to 1 dt over root 3t whole square plus 1. The integration equals to pi by 2 into direct formula. I can put 1 by root 3. This is tan inverse root 3t from 0 to 1. So I2 will be pi by 2 into 1 by root 3 into tan inverse root 3. Tan inverse root 3 equals to pi by 6. Oh, sorry, pi by 3. So it will be pi over 3 root 2 into pi by 3. Step, it will be 2 root 3. by 3. So this will be pi square over 6 root 3 is the answer. Was it an MCQ question? No. So the answer is integration of negative pi by 4 to pi by 4 x plus pi by 4 over 2 minus cos 2x dx equals to pi square over 6 root 3. Answer. Thank you for watching. Integration. Evaluate the integral from 1 by 4 to 3 by 4 cos of 2 cot inverse square root 1 minus x over 1 plus x whole dx. So this is a very interesting question because of course this was a MCQ question, but I have not written the answers. Here so many trigonometry formulas are applied. So let's begin. So for that, let me write the trigonometry formula we'll use here. One is your 1 minus cos of 2 theta equals to 2 sine square theta. 1 plus cos 2 theta equals to 2 cos square theta. So here I'll take x as cos 2 theta so that I can rationalize, or this square root function can be simplified. The square root of 1 minus x upon 1 plus x will be your square root of 2 cos sine square theta. 2 cos square theta, 2 to cancel, it will be sine theta by cos theta. That will be tan theta. So this becomes your tan theta. Next is cot inverse tan theta is written as your cot inverse. Tan theta is cot, pi by 2, it's not cos, cot. Pi by 2 minus theta, that will be your pi by 2 minus theta. So now I am writing the whole function. So cos twice cot inverse square root 1 minus x over 1 plus x. And I am doing the same mistake, it will be, oh, of course it was cos. So this becomes how much? It will be cos twice cot inverse tan theta that is equals to cos 2 pi by 2 minus theta. So it will be cos pi minus 2 theta. Cos pi minus 2 theta equals to minus cos 2 theta. Okay, so now coming to integration. So integration 1 over 4 to 3 over 4 cos 2 cot inverse square root 1 minus x over 1 plus 3x. So I am taking x as cos 2 theta. So minus sine 2 theta into 2 d theta is equal to dx. So in place of dx I put minus 2 sine theta d theta. So since it was in x, now I am writing in theta. So I am not taking the limit. For temporarily I am taking the limit as alpha to beta. Then it will be minus cos 2 theta into minus 2 sine 2 theta d theta, which is ultimately becoming equals to sine 4 theta. So sine theta, sine x into cos x is 2 equals to sine 2x x. Now in integration, sine 4 theta equals to negative cos 4 theta over 4. And I evaluate it from alpha to beta. I'll come back to x, then I'll replace alpha and beta. Now cos 2 theta equals to, we have taken as x. So cos 4 theta equals to 2x square minus 1. Because cos 2a equals to 2 cos square a minus 1. So it will become how much? Minus 1 by 4 cos 4 theta equals to 2x square minus 1. I'll get back to the limit 1 by 4, 3 by 4. So this will be minus 1 by 4 here, 2 into 3 by 4 whole square is 1 minus 2 into 1 by 4 whole square minus 1. That will be plus 1. So minus 1 plus 1 will be cancelled. So this will be minus 1 by 4 multiplies 2 into 9 by 16 minus 2 by 16. So this is equal to minus 1 by 4 into 18 by 16 minus 2 by 16, that will be 16 by 16. So the answer is negative 1 by 4. So this is the answer. Actually the options were negative 1 by 4, negative 3 by 4, 1 by 4 and negative 1 by 4 and 3 by 4. So answer is negative 1 by 4. So thank you for watching. Integrate 0 to infinity 6 over e power 3x plus 6 e power 2x plus 11 e power x plus 6 dx. Each options are log e 64 over 27, log e 32 over 27, log e 512 by 27 and log e 64 over 81. So analyzing the denominator, e power 3x plus 6 e power 2x plus 11 e power x plus 6 will make this whole integral as partial fractions. So I am taking let e power x equals to a, then e to the power 3x plus 6 e to the power 2x plus 11 e power x plus 6 will be a cube plus 6a square plus 11a plus 6. So I will factorize using the factor theorem. Minus 1 is a root of this, or I am factorizing in this way, splitting 6 as a square plus 5a square and splitting 11a as 5a plus 6a plus 6. So this equals to a square taking common a plus 1 plus 5a taking common, a taking common, a taking common and a plus 1, and 6 taking common, again it will be a plus 1. Or this is your a plus 1 multiplied a square plus 5a plus 6, and further factorization it will be a plus 1 into a plus 2, a plus 3. So now I am writing the integral. Instead of writing the integral, I am writing in a term. So 6 a plus 1, 6x plus a plus 2 into a plus 3. We will convert this into 3 linear factor, with linear factor as denominator, a plus 1 plus b a plus 2 plus c a plus 3 to find the value of your ABC. So a into a plus 2 into a plus 3 is b into a plus 1 into a plus 3 plus c into a plus 1 into a plus 2 equals to 6. What I did, I comparing the numerator. What I'm going to do, I'm getting the value of a, b, c. So taking a, b, c orbital constant we have taken, first I'm taking a equals to negative 1, then this b component and c component will vanish. So a into negative positive 1 into positive 2 equals to, right side is 6. So this gives us a equals to 3. Now taking a equals to negative 2, then first and third will vanish. It will become 0. So b negative 1 and 1 equals to 6. This gives b equals to your negative 6. And for c, a will take a equals to negative 3. Then c into negative 2 into negative 1 equals to 6. This gives c equals to again 3. So we got the partial fraction a over a plus 1, b over a plus 2, and c over a plus 3, where a equals to e power x. So writing the original question, 0 to infinity 6 dx over e to the power 3x plus 6 e to the power 2x plus 11 e to the power x plus 6 equals to, now 0 to a equals to your 3 over e to the power x plus 1. Second is negative 6 by e to the power x plus 2. And third is 3 over e to the power x plus 3 over dx. So we'll go one by one. So here we'll divide e to the power x both in numerator and denominator. Then we'll get 0 to infinity. First one will be 3 e to the power negative x over 1 plus e to the power negative x dx. Second one will be minus 6 0 to infinity dx e to the power negative x over here 1 plus 2 into e to the power negative x plus third one will be then 3 dx of course e to the power negative x over 1 plus 3 e to the power negative x dx, and all the integral is 0 to infinity. So here it is your 3 log 1 plus e to the power minus x 0 to infinity. This is minus 6 log 1 plus e to the power minus x, sorry 2 plus 1 to the power minus x, done a mistake, 1 plus 2 e to the power minus x divided by 2 from 0 to infinity, and third one is 3 log 1 plus 3 e to the power minus x 0 to infinity divided by 3. Now getting the value, this will be 3 log 2, because if we put infinity it will be 0, and if it is 0 it will becomes 2, minus 3, this will be log 3, and this will be your log 4. Now simplifying, this will be log 2 power 3 multiplies 4 over log 3 power 3. So it will be log 32, it's not log, 37. One is the answer. Answer is 2 is the answer. If there will be confusion taking this limit, we can take 1 plus e to the power minus x as t, and you can change the limit. It will be 0 to 1. Evaluate the integral 2 over pi times pi by 6 to 5 pi by 6, 8 times of cosec x within the greatest integer function minus 5 times of cot x again within the greatest integer function with respect to x, where box t denotes the greatest integer less than t. That means we know the greatest integer function. If x is your 0 to 1, then greatest integer function is 1. That means it takes the lower value, not the higher value. So knowing this, let us come to the graph cosec x. Cosec x, the limit is pi by 6 to 5 pi by 6. In between, cosec pi by 6 equals to 2, we know. Cosec pi by 6 is 2, pi by 2 is 1. Again cosec 5 pi by 6 is your again same as cosec pi by 6, that is your 2. So the value is from 1 to 2. So cosec x, greatest integer function, equals to your 1 included. That means 1, it is cannot be 2 because we take the minimum value. So it will be 1. So there is no breaking of limit. So here this is your pi by 6 and pi by 2, and here it will be pi by 6, pi by 6. So it is taking only the value as 1. So no need of breaking. It's easy. So we'll write first one is 2 over pi times pi by 6 to 5 pi by 6, 8 times of cosec x dx equals to 2 over pi your pi by 6 to 5 pi by 6 equal to 8 into 1. So I can take 8 outside, so it will be 16 over pi. 1 integration is x from pi by 6 to 5 pi by 6. Your calculation is also simple. So 16 over pi into 5 pi by 6 minus pi by 6, that will be 4 pi by 6. Pi cancel, 2, 3. So it will be 32 over 3 unit. Now coming to second one. Second one is we'll get cot x, test integer function cot x. The limit is interval pi by 6 to 5 pi by 6. We'll see this interval. Here this graph, please see this, observe this graph. At pi by 6 the value is your root 3. At pi by 4 the value is 1. So within this limit it is changing from root 3 to 1. So we'll take the minimum value, we'll take 1. So first interval is your pi by 6 to 5 pi by 6 cot x, greatest integer function. It is your pi by 6 to pi by 4. It will take the value your 1. This is 1 dx, plus then pi by 4 to pi by 2. See, at pi by 2 it is 0. So at pi by 4 to 0 it will be again 0, because 0 is the minimum value, 1 is the highest value. So pi by 4 to pi by 2, it will be 0 dx. Next is pi by 2 to 3 pi by 4. At 3 pi by 4 it is minus 1. So here people compare minus 1 and 0. Minus 1 is minimum and that is the maximum. We take the least. So we'll take pi by 2 to 3 pi by 4. It will be negative 1 dx. And the last is from 3 pi by 4 to 5 pi by 6. This value is your minus 2. So minus 3 pi by 4 to 5 pi by 6, this will be minus 2 dx. So it will broken into four values. It will take 4 values. So this is equal to, now integration of this equals to, please note that I have not taking this 5 now. After I'll calculate. So this will be, or I can write this one also, 2 over pi into 5 times pi by 6 to 5 pi by 6 cot x dx equal to be 10 over pi whole into, now one integration is x from pi by 6 to pi by 4 plus 0, I am not taking anything, then minus x pi by 2 to 3 pi by 4, then minus 2 times of x here 3 pi by 4 to 5 pi by 6, and whole thing this will be 10 over pi by 4 minus pi by 6, next is 0, next is 3 pi by 4 minus pi by 2, last is 2 times of 5 pi by 6 minus 3 pi by 4. So this equals to 10 over pi by 4 minus pi by 6, pi by 12, 3 pi by 4 minus pi by 2, pi by 4 minus 2 into pi by 12. This equals to 10 over pi by 12 minus 2 pi by 12 minus pi by 4 equals to 10 over pi into minus 1 minus 3 minus 3 pi by 4 minus 1 minus 3 4 pi by 4. This equals to 10 by pi into 4 pi by, very sorry, it will be 12. Minus 1 minus 3 minus 4 by 12, there will be pi by 3. Then by 3. So first result was, so integration of 2 by pi by 6 to 5 pi by 6, 8 times of greatest integer cosec x minus 5 cot x dx equals to 32 by 3 minus minus 10 by 3. That will be 42 by 3. The answer is 14. So thank you for watching. Subscribe the channel, like the video, comment down.